So Bits to Waves is it's a one-day course that's focused on trying to teach the overall system concept of radios and also give people the experience of building something. Because one of the things that's been missing in education has been the ability to actually fabricate and build something up. Because today, with the wonderful CAD tools that are out there, we tend to design everything, and then we hit go and somebody else fabricates and makes it. And we lose touch with how things are made, and we also lose sort of the joy in building something ourselves and seeing it work and getting in touch with the actual final product. The class also teaches from an experiential standpoint. So instead of listening to a lecture about how something might work, we actually design. We do a complete layout, we do EM extraction, we fabricate the boards, we populate the boards, and we test them. So you get to go through the entire flow of an actual problem, and that tends to be a lot more effective for people to learn and a lot more fun also.
Let's talk a little bit about the radio that you're going to build. The architecture is a direct conversion transmitter. So you are going to be provided with an I and a Q signal and an LO. What you're going to do is you're going to take that LO and create a sine and cosine, or sine and cosine. You're going to build two mixers, you're going to build a combiner, and then you're going to build a power amplifier and an antenna. This diagram shows two amplifiers, but we're just going to be doing one. Like there are I and Q mixers, there's a Wilkinson combiner, there's a phase splitter to create 0 and 90 degrees, which is the branch line coupler we'll talk about, a power amplifier, the receiver has an LNA, and then both of these have antennas. So these are the different pieces. You're going to be building just the transmitter, so you'll be building everything except for the LNA. All right, here's me assembling the radio with my 4 components. Here's a integrated version, but here are the 4 pieces. So I'm simply taking some connectors, putting it on my branch line, then I'm connecting it up to my 2 mixers, and then noticing that everything lines up. I recommend that you line these up and loosely assemble and then tighten them as I'm doing now. There you go. There we are. There's my 16 QAM constellation, and I'm just using the X versus Y plot on the scope to plot the I and Q. All right, here we are on the website. This is just an introduction that we've already covered in our video so far. I just want to point out to the right, there's a nice drop down where this will take you to each one of the designs, and it will also take you to a theory page that will explain the construction and how each of the components work. We're going to go back to the introduction page, but before we do, I just want you to note that I've actually numbered all the components in order of completion. Start with the Wilkinson, 1, then the branch line, then the mixer, then the power amplifier, then your antenna. And note that we're not using the oscillator in the workshop. I'm going to go back here to the introduction, and we're going to click on the start, and it's going to take me to this page. And this is very important because this is where you're going to download the template. Once you've downloaded it, we can go ahead and get started. This is the complete radio. Once again, I'm mentioning that these need to line up. This is a picture of the test that we'll actually do in the workshop, our student design competition. Here's an example radio. You can see the branch line, the 2 mixers, the Wilkinson, the PA. It's connected to the antenna. This is the part that you will design. When we actually do the testing, we will provide a receiving antenna, and then a receiver demodulator is off to the right. Continue on to the design page, and here we are. Here are the 5 components, 1, 2, 3, 4, 5 that you should make, and each one of them will take you to the same page that each of these take you to. This will take you to designing the Wilkinson combiner, the branch line coupler, the double balance mixer, and the antenna. Let's just go to one of these pages to make sure we understand how the pages work. So this page will take you through how to set up and operate the branch line coupler. If you've never used AWR before, it only takes a couple minutes to learn how to use the software, and then we walk you through telling you every command that you need to create as you flow through here. And as you can see, we go step by step helping you understand how each part works. I'm just going to scroll down to the bottom. And we also tell you how to assemble. And this is just pictures on the foil technique I mentioned to you, where the foil is stuck on. And then we also tell you how to assemble and how to test the individual components.
So I'd like to discuss what you should be doing tonight. You'll have access to a USB file that will have all of the AWR software on it. Please download that software either from the USB, or I'll give you a link shortly where you can download it off of the internet from my site. There'll be a special license key that will give you a license for 7 days. Also, there'll be a tutorial that'll tell you how to install the software, and this is this top part 1 through 14 here. And then there's a short demonstration on how to use the software. It's about 10 minutes to 15 minutes to design a simple component, and this takes you step by step through the software. Please do try to get this done before you come in tomorrow. That way you'll know you'll have the software installed and you will have a simple design done so you're ready to go. Tomorrow we'll start design in the student school, but you can also start the design on your own, and I'll describe that in the next slide. Build for everyone is 8:30 on Wednesday. If you'd like to design on your own, you can open up the EUMW 2018 Bits to Wave PDF, and it contains a step-by-step guide for all components. It contains the Wilkinson combiner, the branch line coupler, the mixer, the power amplifier, the Yagi-Uda antenna, fabrication, and assembly. And as you scroll through here, you'll notice that each section begins with a theory of operation so you understand how the component works, and then a step-by-step design on how each component is designed and laid out, and in this case, EM simulated, and then finally how you'll assemble the parts and how you'll test. Assembly and testing will happen on Wednesday. You should form a team to design each component, one component per person, although if you have a smaller team, some components are easy and a person could do 2 of them. You should design and build them in the order they are in the file. So start with the Wilkinson, and then we'll finish with the Yagi antenna. Note that there's no design simulation for the antenna. It will be designed as it is fabricated on Wednesday, so you just need to design the Wilkinson, the coupler, the mixers, and the power amplifier. So 4 components before Wednesday. This is a brief overview of the expected design time for each component. The Wilkinson will take about 15 to 30 minutes to design, 20 to 40 minutes to lay out, and build is pretty short at 20 minutes. Branch line is just slightly longer due to alignment in the layout, and the building you have to solder on an extra component, so it takes a little bit longer. Typically these 2 components can be designed and laid out and built in less than 90 minutes. The mixer, the design time is pretty short, however there is some layout involved, and then the build can be quite long. And I'll just make a note down here that the mixers are the most difficult to solder due to the very small layout for the balance. If someone is doing the mixer, I highly recommend that if someone in the group has soldering experience or has very good eyesight, this is a good task for them to tackle. If you've never soldered before or you have trouble seeing small items, this may be a challenge for you and may take you an extra long time. The power amplifier is the longest to design with 60 to 90 minutes of design time. The layout is fairly straightforward, and then the build at 60 minutes is somewhat complicated just because you have to solder on many surface mount components as well as your microwave designs. I'll just note down here for the PA, design uses advanced concepts such as load pole and impedance matching. Someone in your group knowledgeable in microwave design, Smith charts, etc. should do this one. One caveat, all of these designs can be done by beginning students. However, some may take longer or be more difficult. In deciding which team member builds which piece, I've given you some guidance. So while I've given you guidance for the mixer and the PA, any students could do all of these designs. Finally, the antenna is not designed in simulation. We simply lay it out based upon some guidance from a previous text, and it takes about 10 minutes to build. Here's the schedule. Today You can download a copy of the software at our website, or you can get it from the USB. An updated license file will be given to you at European Microwave. On Tuesday, we're going to start with a 60-minute lecture. I'll just note that this lecture is already pre-recorded, if you would like, at my website, and you can watch it there. Then we'll start designing the components, and we'll have about 3 hours, which should be plenty. At the completion of Tuesday, we should all have our DXF layout files ready and be given to the instructor. On Wednesday, in the first hour, we're going to cut our copper foil for all our microwave designs. Then we're going to spend about 2 hours building our components, and then the final hour will be in testing. All right, that is about it, except I'd like to show you our website, which has a good amount of information for you. Here we are. This introductory video is posted. My email is posted. This is the link where you can download the software. This is a tip sheet from last year. These are the lecture slides from the introduction. And if you want to start design, you just click Start Design, and it takes you right to the website where the introductory video is, and then on the right is all of the design instructions. These design instructions are exactly the same ones that can be found inside of your book. All right, looking forward to seeing you this week.